linear and matrix forms of systems of equations. When you're solving a matrix form of a system of equations using its inverse, we can use this idea. We're going to create a matrix system here in a moment. Okay, so we're going to say if the coefficient matrix A times the variable matrix X is equal to the constant matrix B, and it has a unique solution, then we can find that X is going to equal matrix A, the inverse, times B. All right, and we can find X, it's the same thing. So we're going to multiply our matrix A inverse times matrix B. Okay, so let me kind of show you this. What's going on here? If I've got this idea, matrix A times matrix X is equal to matrix B. And we're going to work one of these in just a second. But if this is true, then what I can say is I'm going to multiply the left-hand side and the right-hand side by A inverse. Okay. Because remember what we said? That A inverse times A would give us the identity matrix. And the identity matrix times anything is just going to be itself. And so we can say that A inverse times B is going to give us what our variables are equal to. Okay, so let's take a look at this idea. On the left here, I've got the linear form of my system, okay? And so I want to first write it as the matrix form of the system. So I'm going to start by creating a coefficient matrix, and this is this is not an augmented matrix. This is just the coefficient matrix of the variables. So I'm going to have 5, 2, 1 as the first column, 12, 5, 2 as the second column, -1, +2, -3 as the third column. Okay, so this is my coefficient matrix A. And I'm multiplying that by my variable matrix, big X. And so that's just going to be X, Y, Z. Okay, and this is going to equal my constant matrix, and this is going to be big matrix B, 10, -1, and 5. Okay, so this is my matrix form of the system. So if AX equals B, okay, which is what we were saying here, then X is going to equal A inverse of B. So to solve this, if I've already got A in my calculator, then all I'm going to do is multiply A inverse times B. Oh, sorry, 10, -1, and 5. And then my output from that will be my solution. I'll get a 3x1 matrix here. That is my solution. And darn it, I didn't do that ahead of time, so I am not sure what the answer is to that. I'm sure that you can do that, though. So I'm going to just finish this up. We got 2 more little sections here. The determinant. We've actually used a determinant. I just did not tell you its name. The determinant is a value associated with the matrix, and it's a numeric value, and it is AD minus BC. Okay, remember when we used that to find the inverse? So if I'm thinking about this matrix here, I'm going to say that the determinant of this matrix is 5 times 4 minus -2 times 3. In other words, 20 minus -6, which is equal to 26. So the determinant of matrix A in this case is 26. This can be done by the only thing that I'd like you to be able to do a determinant of by hand is a 2 by 2. The 3 by 3s are not difficult, but they're a little more time consuming. And so I'm going to say just get that from your calculator. And again, you input the values in a 3 by 3 matrix for matrix B, and then go to your math menu in the matrix menu, and you should see a command called DET, which stands for determinant. So you would just do DET and then tell it you want it of matrix B if you've already put matrix B in there, and you should end up here with a value of 52. Now, one thing to remember is determinants are numeric values. They're not matrices. They're just one number that's associated with the matrix.